Hey everybody, thanks for tuning in. So this is going to be part 2 of our lecture series here on the nature of stars. And so in this lecture, we're going to be focusing on describing how bright stars are. And so if you look at this picture here on the right, one thing you'll definitely notice is that the stars have a lot of different colors. You can have red stars, you can have blue stars, or somewhere in between. But we're going to get into that later in terms of what the color tells you. What we're going to be talking about is when you also look at this picture, the stars here have different brightnesses. So some can appear really bright, and some of them can appear really faint. And so when astronomers describe the brightness of stars, we use this thing called the magnitude scale. And so the magnitude essentially is just a number like 1 or -1 or 10. But that tells you how bright a star is relative to like some standard star that we chose. Okay? And here's the thing about the magnitude system. It's not very intuitive. In fact, it's actually an archaic system. And we still use it purely because of historical reasons. And this was created by the astronomer Hipparchus in the year 850 when he was outside just looking at stars and just started classifying the brightness of the different stars that he was able to observe. Okay, so now let's just see how this works. Okay, so in the magnitude system or the magnitude scale, the larger the magnitude, the fainter the star, and the smaller the magnitude, the brighter the star. Okay, so if you look at these two pictures on the bottom here, you can see there that the star on the left is obviously fainter. It's harder to see, and so you would assign that a larger magnitude number. So let's give it like some number like 9 or something, like magnitude 9, right? And if you look at the star here on the right, then it's a lot brighter than the star here on the left. And so you would assign that a smaller magnitude number. So let's say it could be like 1. Okay, so that tells you that that star that has a magnitude of 1 is much brighter than the magnitude 9 star. And so now this is why it's kind of intuitive, because usually when we think about numbers, the larger the number, the more something that number represents. So like, for example, like money, the more money you have, the larger the number in your bank account, right? And so in the magnitude system, it's kind of like an ascending order. It's the exact opposite. The smaller the number, the brighter that star is. And if you're curious why that works that way, it's because when Hipparchus was classifying these different stars in the night sky, he basically said, "Oh, look, that is the brightest star. That is the number 1 brightest star in the sky. That is a number 2 brightest star in the sky. That is a number 3 brightest star in the sky," and so on and so forth. So you kind of get the idea how that works. And then when it comes to our naked eye, we have this calibrated such that the faintest stars that our naked eye can see, so without the use of any telescopes or binoculars or anything, are of the 6th magnitude. And so ever since Hipparchus, now we have telescopes to use, and so for him, when he first started classifying stars, he basically used the number 1 as the brightest star. But because we have telescopes, we can actually go much brighter than that. And so that gave us the reason to actually start using negative numbers instead as well. And so if you look at these two stars again, for example, the star on the right here, the really bright star, that could be actually -5 or something like that. And so the larger the negative number, the brighter the star is. So you can probably guess that if you had to classify the sun as some sort of magnitude number, then it will be a really, really negative number, because it's the star that is closest to us, but at the same time, it is also the star that is brightest relative to us. Okay? All right, so let me just tell you that there are actually 2 types of magnitudes, because we're actually trying to find out the physical properties of the star. This gives a rise to 2 different types of magnitudes. So type 1 is called the apparent magnitude. So apparent basically just means like the obvious, right? And so this means that if you were to see a star in the sky, this is how bright that star would be seen when it appears from Earth, or as you see it here from Earth. So you look outside, you see a star, you're like, oh, that is like magnitude 1. So that is the apparent magnitude of the star, okay? So that one's pretty straightforward. And the second case, case 2 here, is called the absolute magnitude. And so this is the magnitude that you would assign to a star if, hypothetically, you were to move it 10 parsecs away. So imagine if you were to take the sun, which is a really small magnitude number because it's really bright, you would move it 10 parsecs away and then reassess, like, okay, how bright would the sun be if you were to move it 10 parsecs away? And so the reason for why we have this is to allow a fair comparison as to how bright stars actually are. Because hypothetically speaking, if you were to move stars all at the same distance, then now you can make fair conclusions about which star is actually emitting the most light. So, therefore, you can actually have a star that can have a small apparent magnitude, which means it's appearing bright as you see it here from Earth, and then have a really large absolute magnitude number. So if you were to move it 10 parsecs away, it turns out that star wasn't actually that bright. It's just because it was actually really close to you, that it appeared bright to you, okay? Or you can have a star that has a large apparent magnitude, and the reason for why that could be is because that star is really far away. But then if you move it 10 parsecs, so you're moving it closer to you, then it could have a small absolute magnitude. So it turns out it's actually emitting a lot of light, but relative to you on Earth, because it's so far away, then it looks faint. Okay, so if that's all confusing, here's another analogy. Instead of using stars, we can use cars. Okay, so here are two cars, car A and car B. They're identical to each other, but for some reason, car A's headlights look brighter relative to how you're seeing them. So how is that possible? Well, the simplest explanation is that car A is closer to us. So in this specific scenario, you would assign car A to have a smaller apparent magnitude, and then you would assign car B to have a larger apparent magnitude. But here's the thing, if you move it at the same distance, they would have the same absolute magnitude because they're two identical cars. So case number 2 here, let's say you have car A and you have car B exactly at the same distance from you, but car A's headlights appear brighter. So how is that possible? Well, the only explanation for why that is because car A's headlights are actually brighter. In other words, car A is emitting more light than car B. Because now it's a fair comparison. They're at the same distance to you, so you've taken that factor out of the equation. So car A's headlights is simply just emitting more light than car B. Okay? All right, so now let's go back to stars here. So now if you look at this observer, so imagine you're this observer seeing these two stars, stars A and star B. Star A is actually closer to the observer than star B. So relative to the observer, which is basically the bottom panel right here, the observer will see star A brighter than star B. So in this case, the apparent magnitude of star A will be of a larger number than star B. Well, actually, no, excuse me. It'll be a smaller number for star A because star A could have like an apparent magnitude of 1, whereas star B could have an apparent magnitude of like 5, for example, because star B looks fainter. Okay, however, now if you were to put both of those stars at the same distance, say 10 parsecs away, well, from the side view here, you can actually see that star B is the one emitting more light than star A. So if you were to shift this star A at the same location as star B, and let's say that's 10 parsecs away, which will give you the absolute magnitude of that star, then star B will have a smaller absolute magnitude, meaning it's actually brighter than star A. So the absolute magnitude of star B could be like 1, and then the absolute magnitude of star A could actually be like 5. Okay? All right, so it's a little confusing, but it does take some practice to get used to this system. Okay? And once you are able to figure out the apparent and the absolute magnitudes of these objects, you can actually infer some information about how far away they are relative to 10 parsecs. And that's the idea here. All right? Okay, so with that being said, that's about it for this lecture. So in the next lecture, we're going to be discussing about the temperature and the colors of stars. Okay, see you guys next time.